When we think of data giants, we think of modern tech companies, right? But what if I told you one of the biggest data stories out there comes from a 100-year-old manufacturer? The numbers behind this company's data operation are, well, they're absolutely staggering. They might even make Silicon Valley blush.
Okay, quick question for you. When you hear the name Rolls-Royce, what's the first image that pops into your head? Yeah, for most of us, it's probably one of those super luxe cars, a real symbol of wealth and classic design. And look, you're not wrong, but you're also not thinking nearly big enough.
Because get this, the car division, that was sold off decades ago. The Rolls-Royce of today is a titan of aerospace and defense. Their actual business, their real power, isn't on the road. It's thousands of feet up in the sky. Yeah, the modern Rolls-Royce is all about powering the skies. We're talking about building these colossal engines for hundreds of airlines and military forces all over the world. In an industry like that, where failure is just not an option, they had to turn to one key resource to dominate: data. So the whole journey for one of these incredible engines starts way before a single piece of metal is ever touched. It actually begins its life as pure information. Think of it as a digital twin, an exact virtual replica living inside a massive computer cluster. Their chief scientific officer, Paul Stein, really puts it into perspective. He says we generate tens of terabytes of data on each simulation of one of our jet engines. But here's the kicker. It's not just about having all that data. It's about being able to see it, to visualize the incredibly complex physics, to know if a design is actually going to work. Just let that sink in for a second. Tens of terabytes. To give you some context, that's like having the entire print collection of the Library of Congress generated multiple times over. And don't forget, that's for one single simulation of one engine design. They run countless versions of these, testing every little variable. This engine has basically flown millions of virtual miles before a single part is even built. Okay, so once that digital design is absolutely perfect, you've got to make it real, right? And this is where the factory floor becomes its very own data ecosystem. They pull this off using something called the Internet of Things, or IoT. Now, put simply, this just means that all the sophisticated machines, the robotic arms, the automated measurement tools, they're all connected. They're all talking to each other, constantly checking for quality and tweaking the manufacturing process on the fly. And believe me, the numbers coming out of the factory are just as mind-blowing as the design phase. Take a look at this. 0.5 terabyte. What on earth could possibly generate that much information? That is the quality control data for one single fan blade. Now think about this. Their factory in Singapore makes about 6,000 of these blades every year. So if you do the math, that's 3 petabytes of data for just one component. Every single blade has its own incredibly detailed digital birth certificate. So we've got an engine that was born from data and then built by data. But the story doesn't stop there. Oh no. In fact, it's really just getting started. Because the second that engine is attached to a plane, it becomes a flying, talking data center. So here's how it works. You've got hundreds of sensors tucked away inside the engine, and they're monitoring every little detail of its performance. If they pick up on the tiniest anomaly, like a slight change in temperature or a weird vibration, that data gets beamed to engineers on the ground instantly. They analyze it, and here's the magic part. They can schedule maintenance to fix a problem before it even happens. And here's why this matters to you and me. This proactive approach saves airlines a ton of money on fuel by making sure the engines are always running at peak efficiency. And it prevents those flight delays and cancellations that we all hate, because maintenance can be scheduled days or even weeks ahead of time. No surprises, no disruptions. So this complete command over their product's data, from its digital birth to its physical creation to its entire life in the sky, it allowed Rolls-Royce to do something truly revolutionary. It let them completely change how they do business. Just look at this shift. In the old days, an airline would buy a jet engine for millions of dollars. Simple, right? A product sale. But now, under their total care model, most airlines don't even buy the engines. Instead, they pay a fee for every single hour that engine is running. Rolls-Royce keeps ownership, and because they're so confident in their data, they cover all the maintenance costs. They're not selling a product anymore, they're selling a service. Guaranteed, reliable power. And as Paul Stein says, this was an absolute game changer. Their mastery of data created a business model so powerful that their competitors pretty much had no choice but to try and copy it. And this is what brings the whole story full circle.
The terabytes of data streaming back from thousands of engines in the air don't just help with maintenance. All that information is fed right back into the very beginning of the design process. It creates this incredibly powerful feedback loop. So the life of every engine in the sky helps inform the birth of the next one, making it more efficient and more reliable. So this leaves us with a pretty powerful thought to end on. Rolls-Royce proves that literally any company, even a century-old industrial giant, can transform itself into a data company. It just goes to show that the data revolution isn't just for startups in Silicon Valley, it's for everyone. Which leads to the real question here. If a jet engine maker is a data company, then what business isn't?